Hi everyone. So I hope you have already have taken the overall review of NestJS. Why NestJS? Why should you use NestJS instead of any other Node.js backend framework like Express, Koa, HappyJS, and the basic differences between the NestJS and the Express. Here I'm just going to give a quick recap and then start with our topic. So Express is unopinionated, flexible. NestJS is a modular and a forced structure. That means you will write controller, module, services, pipes, interceptor, middleware, and all. Dependency injection is totally resolved with the NestJS. Here we need to use a new keyword to create the instance of the service and pass that in the controller. But NestJS has a built-in repository, built-in dependency injection, where you can inject the repository and we can just use this dot repository dot method names. So that is possible because NestJS provide dependency injection. There are a lot of other things like middleware are simple in Express, but here also we can create a logger middleware, auth middleware, and we can apply them for a particular set of routes. Here inside app module, we are saying that I'm adding a logger middleware for all the routes, excluding the health route. Error handling is kind of a similar. This is how we define controller and path. So this is all about like the differences, the major differences we see with the Express.js and the Nest.js. Now coming back to our topic, what are the building blocks of Nest.js? From even Nest.js website, you will find these are all the building blocks: controller, provider, modules, services. These are 4 5 core building blocks. Then we have interceptor, filters, pipes, middlewares, and all those things. So what is controller? Controller is nothing but a router in the Express MVC world, where we define the API routes. Users get user by ID, create user, update user, or delete user by ID, right? Provider and service. Provide contains a business logic and these services will be injected inside a controller so that they provide a data like user service. This contains the mock user object, and this will provide those that user object through these methods: find all, find one, create. It's like a CRUD operation using some mock data. Middleware functions are executed before the route handler. So there is actually the life cycle flow in this. All these things gets executed. Let's say I built a NestJS microservice or API, like let's say public API get list of users. So how the request will go through one set to another set. So request comes, it will enter as in the middleware. Then it will go to the guards, then interceptors, then pipes, and then it will reach to the router handler. So you can see there are 4 things which are acting before even we reach to the router: middleware, guards, interceptor, and pipe, and then exception filter to update the response. So these all are different building blocks. Middleware guard determine if request should go to the route before checking the roles and all those conditions. Interceptor, if you wanted to intercept the request and do some calculation processing. Pipes, pipe used to transform the input, validate the input, check the like joy validation or jod data validation. Similarly, the pipes can be used, these are validation pipes, can be used to validate the incoming data inside a payload. Exception filters, if you wanted to expose more information about the stack trace, status code, message, then you can use exception filters to return more information about what has happened to your API request. DTO, data transfer object, these represent your request and response. So overall, when a request enters in any framework, let's say NestJS, it has a request and response. So in typical API, we validate the request response, then the middleware will come into picture. It will validate or check few things about role, authentication, authorization, then it will go to the routes. Here, these are same thing. We have middleware, we have pipes, we have interceptors, and then it will go to the route. So these are core building blocks of NestJS. So let's look back again on our Nest CLI project. This is how we have started a simple project, Nest new, and this project has been created. We will look into the folder structure which has been created like auth microservice. Nest new auth microservice, it will create this project, and these are different files inside it. It has a simple controller, one service, one main.ts, test folder, and all. If you look inside this, these are the core dependencies on which the NestJS is running. Dev dependency contains the ESLint, TypeScript Express, testing, semantics, CLI, super test, TS jest, because it is using jest for testing, and ESLint config, prettier, some plugin for ESLint prettier, ESLint plugin prettier, and some ESLint modules like TypeScript ESLint parser, TypeScript ESLint plugin, the basic dev dependencies which we don't need to worry much about. Now if you look into the source folder, here we have module. So this is root module, and then there is a service. So this is how we are actually navigating and checking all these path and the folders. So inside package.json we have all these dependencies of ESLint, node, supernode, jest, express, types. Type definitions will be added inside a dev dependency of our project. Now we can start this project. Whenever you do npm run build, what it does, it creates the dist folder, right? And the dist folder contains the compiled JavaScript code. You can see here inside dist we have all the code which has been created, and this is happening because we have tsconfig, that's a build configuration, and tsconfig.build.json is to build the source code. Okay, so target is target, source, and out directory, and what is the module resolution you are using, and output directory is build. Let's say if I change it, then npm run build, it will give me the build folder for the compiled JavaScript files for the TypeScript. This is the ESLint RC which enforces the ESLint rule over our code. It is using plugins and the parser. This is our root module which is importing app module and starting the application. This is app module where we are specifying all the controllers. Provider means services, and then app module. So this app module is being used. Now your applications won't be that small. In the production ready or some big applications, you will have multiple modules. Currently you see only app module, but that is a root module. Underneath that, in the whole application, you can have a user module, course module, profile module, any kind of auth module. These modules all will be imported inside a root module, which is app module. Because when you say app module or root module, that means that is the summary of the whole application. You have to import all the modules inside a root module, so that you can just do nest factory.create and passing the root module inside it. So we can create a multiple module that can be a folder based. So in our code, we can create a, let's say, core module, shared module, auth module, course module, and those modules, because modules enhance the encapsulation. That module will have its own controller, its own services, DTOs, providers, and all the things. So you can see I have created a folders like auth, core, shared, user. So all the shared things can go, shared services can go in shared folder. Core things like core interceptors, shared interceptor, validation pipes, filters, exception filters can go inside a core. Authentication related controller and services will go inside a auth. User APIs like user controller, user service can go inside a user folder. So I have app, which is a root, and inside main.ts we are importing the app module from the app folder. So your main.ts needs only one root module. That root module will import all the other dependent module like auth module, user module, shared module, core module inside app module. So app module is the root one which we are passing. Now rest we have controllers, services, and all. This root module is outside all the other sub modules. It's directly inside source folder main.ts and app.module.ts. And this is how we define the path of our APIs, like line number 4, API v1 user. And you can see when we starting the application, we can see the same API v1 user, get, put, post, whatever the methods you have defined in your code. Port is 3000, so we can actually hit localhost 3000 and API v1 user. So it will hit the controller API v1 user, and HTTP GET should give hello, because it is calling get hello of the service. So service get hello is returning hello world, so it will return me that. So these all are actually some terminologies which we are going to use throughout our sessions. Middleware, guard, interceptor, pipes, controller, exception filters. So controllers, which are defining the routes. Service layer, which is giving us the data, provider and service. Modules, which is encapsulating things together, like auth module will have a auth service, auth controller. User module will have a user controller, user service, user DAO service, user DTO. Middleware, because these are the core concept, core aspects, shared aspect. Route guards can be a specific to a particular module. Validation pipe to validate the incoming request. Database entities, pipes, and interceptors. Now, if you take a look onto the code closely, here in the controller, we are using @controller annotations. These are TypeScript annotations which you see here and there. And here we are injecting app service inside a controller. Controller is calling that app service dot particular method name. At line number 5, we are putting controller API v1 user. So that will define API path. And then there is app service. So we are writing injectable in the service. What does that mean? Injectable is actually a decorator or annotation which you need to add for the TypeScript classes. Those are acting as an injectable service. This @injectable will be used by DI system, NestJS DI, to it will make that service injectable inside any other entity, mostly another service or a controller. So that is being scanned by that NestJS DI engine. It will scan, okay, this is a service. If that service is available inside another module service, then only it can be used. Otherwise, it will result in an error.